Hello everyone, I'm Tao Xu. I'm from Northeastern University of China. I'm a professor in rock mechanics at the Center for Rock Instability and Seismicity Research in the School of Resource and Civil Engineering. Northeastern University is located in the capital of the Liaoning Province, Shenyang City. It's one of the double first classes university in China. There are over 40,000 students. Here are some of the campus photos. In summer, the maximum temperature is about 30 degrees, but in the winter it's very cold. It could be minus 25 30 degrees. My first visit to 3G Deep Earth Energy lab as an Australian Endeavour Award holder in 2012. I've been there for 6 months. It's my first visit to Australia. There are many good experience and good memory. My another twice visit to 3G Deep Earth Energy lab is in 2016 and 2017. During my stay at the 3G Deep Earth Energy lab, I mainly performed the experimental test and numerical simulations on rock deformation and fracturing. We co-authored and published some international journal papers in engineering geology, journal of petroleum science and engineering, outer geotechnical, and minerals engineering editor. This is a photo, group photo, for during my second visit to Monash University in 2016. It's me. I also invited Professor Breakage to NEU for cooperation. He delivered some lectures and international some course. My research interest focused on the time-dependent deformation and fracturing of the rock. As we know, the deformation and fracturing of the rock mass is time-dependent and also rate-dependent. I use different numerical methods, such as the FEM, DM, and the numerical manifold method to study the deformation and fracturing of the rock. Here shows the numerical results on the uniaxial compression and Brezhnev test. And this shows the crack initiation, growth, and the coalescence. This shows the creep curves and the creep string curves during the rock deformation and fracturing. This shows the grain-based DM model. We studied the fracturing and the creep curves. We also use the numerical manifold method to study the initiation, propagation, and the coalescence of the crack in rock, and also study the slope stability and then slide. We also focus on the cross-coupling between fluid and the rock. We study the probability evolution during the damage and fracturing of the rock. I also studied the microwave-induced rock breakage. Here shows some of the results on the experimental results and the numerical simulations induced by the microwave radiation. I also studied the stability of the open pit mine rock slope. Here shows some of the results. We built the 3D model and do some numerical simulations. Our group team, the CRISR, we are developing the mine hazard early warning systems. We aimed at to do some numerical simulations for the open pit coal mine, and also combined with the microseismicity monitoring to make earlier warning on the stability of the open pit rock slope. Here we can see some of the results on the strength evolution, and also shows the stability, which part of the stability. That's all. Thank you. It's a pleasure to be contacted.